started the stream, and then some new pop-up came on the screen I hadn't seen before. So anyway, give it a few seconds, see if anybody chimes in. It's been a while since I've logged in to see if I can check out the stream from here at the same time. I'm on the phone. Studio. Maybe I could just go to my own channel, maybe. That should show it live. Here it is. I don't know if it'll let me see the old chat myself. Man, it's been a while since I've used any of this. Let's see. Got the volume. I just want to see if it's smooth. I'm testing out streaming while I'm connected to my Wi-Fi, which is the one upstairs. Yeah, I don't look too bad. Let's see if I can hold this and read it. It's kind of shaky. I'll hold it for a few seconds. It doesn't look too bad. Anyway, I just thought I'd just make a live stream. I haven't really had the time to like upload anything and edit it and upload or whatever. So I've been slowly plugging along out here on my little controller. It's pretty much ready to go ahead and take off of this little test apparatus and mount it on something and probably get it hooked up in my Frankenstein water heater. But I'm kind of just been messing around with this the last couple days and tweaking the code just a little bit here and there. So these two stepper motors just represent the outdoor electronic expansion valve in the indoor one over here. And I kind of refined the code there a little bit as it goes through. It's reading my thermistors. There's all my temperatures. I think I showed this in a video already. I don't know if I even uploaded it or not, but see right there, I had to do some custom characters and upload it in the LCD just to make space and everything. So I put the ID and OD sideways there, which is I just kind of laid out myself. Might still have the. Here's a scratch pad for that. This is kind of how that stuff works. I have 3 different custom characters. Besides, 4 altogether. I'll show you the other one. But EV on side. I can't remember if I even wound up using that or not. And have OD and ID. I think I wound up taking this out and it looked better with EV going normal and then that side, sideways just for space. But basically, just take your character and generate it, and just you got a 5 by 8 pixels. So it's 5 pixels by 8. So you just, all it is each row of 5 is just 5 bits. So ones will be wherever it's illuminated and zeros where it's not. So this just makes my shapes basically, and then you just got to convert it to hexadecimal and feed it over into the LCD when you upload it. So there's those 2 are custom, and then right here the hack-free HF going sideways. Oh man, went out of focus. So right there, you got water heater, 140 something degrees. I just have all these as my thermistors right now. So it's like 145, space is 54, 84 for the outdoor, and then I have indoor coil, outdoor coil, the inlet, what's going in, and then the suction, the common suction, and then it just uses the indoor or outdoor coil basically, just depending if you're using the indoor or outdoor coil. So it'll adjust the superheat. So if I turn on the thermostat, which would be that, it says AC only, the mode, and then it's going to open this expansion valve right there, which it just did. I just put this tape in this little thing so you can just visually see it. It's going to start up the compressor. And this is going to go through all the little different subroutines. And I'm refining these as I go. Keeps reading the data. checking the modes, seeing if it needs to switch modes. Right now it's in a delay because it just started the compressor. There goes the outdoor fan. And, it doesn't adjust the expansion valve at first. So I have a pretty short delay just for the sake of me waiting for it, still counting down to 3 now. Before it starts adjusting the expansion valve, once it's out there, I'll add a little bit more. You need a couple minutes to get the refrigerant to settle in and the refrigerant copper, to be something where the thermistors can start accurately reading. All right, this is my coil inlet, and this is my common suction to the compressor. Start adjusting the superheat suckers. So I have a couple different things looking and checking the outdoor fan speed, which is coil temp. 84 is in that sweet spot, so it's just staying at the speed it started at. Now, so it says superheat is only 6, so it's closing the expansion valve. It goes through that subroutine. Every time it goes through there, just going through the screens is enough delay, so there, just closed it again. Huh. That fan just wigged out my voltage a little bit for some reason. Must have the that thing set speed up the fan. That was kind of weird. Thing's been working perfectly, so it's still closing. And then so if I just turn my suction temperature up, oh, you know why this is changing speeds? I think I'm leaning on the wires right there. So now it's got more than 12 degrees superheat, so it's starting to, it'll start opening, which is going to go clockwise looking down, or counterclockwise if you're looking from underneath. So now it's opening EXV to lower superheat. So in the real world, as it keeps opening it, the superheat will start correcting. And I can kind of get this in the sweet spot where it just stops adjusting. There's been a little too much there. Pretty sensitive. These are a bunch of just 100K cheap potentiometers, and I just put some resistors on there to kind of get them right in the sweet spot there. Trying to get this in the spot where it stops adjusting. And then the outdoor fan is the next little thing, and see if the speed control's happy. So I'm going to turn the temperature up on the outdoor coil. The fan might already be pretty loud in the camera microphone for all I know. So the temperature is 106. Alright, so next time it should definitely start speeding up the outdoor fan. It's the function after see the function's happy, the superheat's right on. Now just sped up the fan. And I put little silly graphics in there saying that it's adjusting it. So it's either going up or it's going down. And speeding up more and more now. Speeding up there. Go ahead and turn it down, turn it the other way so it won't be too loud in here. It'll start stepping down. Sped up because it went off the last time it took a read. Now it got to new read, it's going to be colder, so the next time through that subroutine it's going to slow it down. There it goes, starting to slow down. So let's see what he's saying in the comments there. Yeah, it doesn't hunt because it, looking at the comment there, just because there's enough delay that it can't overreact. I'm not doing a full PID, having a brain fart. I know what the P stands for, I just can't say it out. My mind is thinking in the integral and derivative. So basically, it's like trying to adjust a faucet to start filling a sink. You open it so much, and then you're looking at the correction like, all right, I want to get to this level, and then you just slowly start increasing to get rid of that error. And then as it gets closer to hitting its target, then you start decreasing it like derivative, and start because you can see it's going to hit the target. So you start backing off. For this kind of control stuff, I haven't needed to do that. I kind of at first tried to do that on the first little processor I built, when I was doing them on these small boards, the smaller chip. I was trying to do all sorts of stuff where it would like, if it was a bigger difference, error, it would like kind of correct it faster and stuff. But I wound up kind of really making it way more simple. And I might walk out there and kind of show you the unit that's running outside, but it's been fine. The EXVs, I just have a kind of a decent sweet spot to first open it to, and it gets it in the ballpark, and then it starts adjusting. And then the one thing I haven't programmed in here yet, which I do have programmed in the other one, is when it finishes the cooling cycle, it was saving that EXV position and then opening on the last one. I might have taken that out. I think it still worked even without it, but I don't know. But that's generally the way they do work in the real world, is because you think if you're just going to come back on in 5-10 minutes, the conditions aren't that different. So just start where you left off and start making adjustments. So, but for this thing, it's been pretty good. And then with a fan motor too. So, but so far, that's been the easier part. But the other thing is, so I have all these crazy functions in here that make this thing see, like, while it's cooling, while this unit is cooling, the high wall, and then all of a sudden my water heater says, "Hey, I'm gonna start heating now." And this thing happened to be on. It's just, it'll do different things. So the simplest thing is, it's in mode 3. I made all these different modes, right? Mode 3 is AC only. So if I switch the water heater on, there's only one difference it's going to do. I'm going to keep this here so you can see the LEDs, but it's going to go mode 2 hybrid now. I don't know if you can see that. And then this, when it does switch, whoop, there goes a pump went on. That's the only difference from AC only to hybrid, is that you're turning on the pump and you're going to start rejecting heat in the water heater. But let's say the AC doesn't need to cool anymore, right? Well, I don't want to overcool the space in those conditions, so it's going to need to switch from this coil to the one out there. So I wound up, for now, having programmed just to do that on the fly. So the AC thermostat goes off. Oop, I almost changing speeds there again. So it's going to change to mode 1 now, water heater only, and then it's switching. It closed that expansion valve and opened this one for the outside while everything's still running. And the indoor fan is off. This is the indoor fan. I forgot to show you that. The reason, and then it's speeding up the outdoor fan because it's in heat pump mode. You're using the outdoor coil, so I just need to drive the outdoor fan faster. So that's what that's doing. And then there's another thing I have in there. A couple different situations. So say it is only calling for the water heater, which it is now, and not the thermostat. I have a low limit with it, because if I put a wall sensor here and another sensor in the water heater, so my microprocessor knows the current temperature of the space of the room and the current temperature of the water heater, it has a high limit for the water heater to go ahead and just keep rejecting heat in the water heater as long as possible, like overshooting my water heater's thermostat. Where that'll come in handy is when I need to cool the room. Well, go ahead and keep rejecting the heat into the water heater, energy, using the energy anyway to cool the room. It's the same energy. Just go ahead and keep putting heat in the water heater. And then eventually there will be a high limit on that where you don't want to overheat the water. So I'm going to have a sensor in there for that. And then the one in the room, the same likewise. If I'm only heating the water and say this is set back for 80 because I'm not home or something, well, it's going to say, well, go ahead and cool the room though until it hits a low point, like 72 or something. So that's the space temperature one, which right now I have it's going to be like 60 something right now, right? Go to the next time it reads right here. Space 55. So I'm just going to crank it up. So it's kind of way up there a little bit. It's going to switch modes again. Reading thermistors. 106 in the space. Turn that a little far. So now it's going to be like mode switch, water heater to hybrid. Now it's going back to hybrid. It's switching expansion valves, going to the indoor one. Compressor's still running. I think switching that fast, it ain't gonna screw anything up. We'll see. And so you got the indoor fan on, got the compressor on, got the pump for the water heater on. And if I flip this switch on, it's the same mode. It's still going to be hybrid. It read that in there, but it doesn't change anything. So then at this point, let's see, put the water heater down real cold. And if I turn off my AC, or the other way around, water heater. So AC's calling, not the water heater because it's off, but the water heater's cold. It's still going to be in hybrid. So still mode 2 hybrid. This probably ain't coming through because of the live stream, but right, because my water heater's cold. I'm just using potentiometers right now. So if I go and crank up the water heater above its high limit, which I just turned the potentiometer, now it's going to see it's 146, right? I have it set for 140 in here. Mode 3 AC only. It's going to do this switch thing again. Or actually, it's already, expansion valve's on the right one. The only thing that changed here, shut off the pump. Because I want AC, so I have the AC indoor fan on, I got the compressor on, the pump's not on, and it's using the indoor expansion valve. And so then, while I'm cooling, like right during the summer, and then the water heater gets used a little bit, gets below, the high limit, but yet maybe it's even above the thermostat setting on the water heater. I don't know where that potentiometer went until we see it here. 124. So 124 is below the high limit, so it's going to switch to hybrid. And when it does that, it's going to switch this freaking pump back on. There it goes. It's the only difference. So some of the changes as it's changing modes is only going to change like whether it's going to reject heat into the water heater or not. So it's going to turn on the pump, turn it off. Some of them are switching to where it needs to go. Okay, don't cool the room anymore. And it's going to switch to the outdoor expansion valve. And then once I'm here in this time of year, right now, it's only going to pretty much just be using the outdoor one and not be switching into hybrid, really. Although, if I close this door here December the 12th, the heat in this room still heats it up. I think there's a little warm now because it's kind of close to the TV, but it's in the 70s in here. If I close this door and keep it shut, it still gets over 80 in here. So I knew I wasn't going to need a heater in here. I just regulate the temperature now by how much I open the door to the garage, So let me check the comments for a second again there. Kind of just focus this on there, but yeah, I wish my compressor, I could run the, and that's the inverter compressor instead of that fixed speed rotary I put in there. I do have stuff to make. I mean, it's going to be another hurdle for me to learn and do, but I should be able to do it. But this here is somebody else actually already has it laid out. It's using the same processor. I just have to adapt it to my XC8 code, which is really similar. And now I know enough about it that I can just look at what the other code was and how mine works and just make the adjustments. But this is yours and how mine works and just make the adjustments. But this is your permanent magnet DC motor, like an ECM or whatever. These are your 3 wires. These are your 6 MOSFETs, right? And then you got to have these 3 driver chips. And they just switch from the low voltage to the high voltage. These are pretty common chips. I've bought everything that's actually those exact parts in here, right? And then here's your, you got to do zero crossing, which is you're doing with resistors. So this is for like lower voltage for like 30 to 60 volts or something, right? So I got to adapt this, probably put some bigger resistors right here. But I'll have to experiment with it because you're taking voltage from the high that's outputting to the motor, and you're dividing it down and feeding it into comparator circuits. The actual comparators are inside those microchips, and then so basically you do this resistor network, right? And then when you come through here, this one winds up being like this common one that you go up to the positive reference, and then all these are going into negative references, it looks like. And then what it is, it's a zero cross. And when the motor, which I can show you easier out here, here's an ECM. I was messing with this one and it was locking up. Well, freaking two of the magnets are freaking popped off. See, screwed it up. But when you're in there, you got your 3 magnets, and there's like there's going to be another, like probably an even number of these windings in here. But it's just the way it works. But as you're going to, you have 2 windings. You're always going through and powering like 2 of the magnets, and one's unused. So right when you, as this is rotating, there's always an unused one next. As you pulse one, the microprocessor, it just happens to work this way, that the one that's not being used, you're looking at it for that zero cross, and right when it moves and zero crosses, it's ready to now do like these 2, and then it rotates a little more and it sees this, and that's going to go to these 2, and or whichever way it goes. But that's how it works. This is a smaller one. I actually took the electronics out of this one and made it into one without a controller in it, and running it on this external controller I got real cheap on Amazon to mess around. And I was just putting 60 volts with all these batteries, and it kind of does run this motor. I don't know if I have it. I don't know if I still have this hooked up or not. Hopefully this is still working okay on my Wi-Fi. That does spark like that when it charges capacitors. Yeah, see the motor spinning. This is a motor out of one of those high walls that had its own chip in there. I can slow it down. Oop, too much. But this thing's not the voltage source, and everything doesn't really match the motor. And I had that hooked up to this, and this thing would start wigging out, and then it would I took it apart, and I'm like, oh god, 2 of the things broke. I have all these motors that are, I have them for a reason, right? Because something was wrong with them. Well, I have this motor here, and that one there, and I put new bearings in it. I think I did. Or no, that has broken bearing, but it's still the armature. The shaft is separated from the armature on that, so it slips. Then I finally found this one. I got to show you this in a few minutes before I stop the live stream, because this is a homemade thing that's running a 460 volt off a 110 with no transformer. You guys will get a kick out of that. But I wanted to go outside. Let me know if I need to put up the comments. Chat, there it is. Hey, T and Z, you're late. Anyway, oh, I didn't know it was raining outside. So let's go out here. Where the heck's the flashlight? I'm trying to see. They moved it. Where's the light button on this thing now? Save highlight. Nope. Wow, they moved. Wow, this app moved the buttons. Let me grab a flashlight. That's not on the phone. Bring up the chat so you guys can tell me if it's not working. There we go. Tell me if it's. I got rid of my Cox internet, and we have Verizon 5G, believe it or not. And I'm actually still connected to it, and it's way on the other side of the house. Oh, see, it's running, okay? So, if it messes up too much, I'll disconnect the Wi-Fi, and hopefully the stream just keeps going on the 5. But here's the other processor that's been running. So indoor coil 43, suction 39. Huh, that's weird readings. So I have it at its hard limit, and it's just not adjusting no more. I need to go in there and take some of that limit out, because I've been finding that with it too cold and the suction, the superheat being too low, I don't think I'm getting the compression ratio sometimes, and the hot gas lines. Yeah, see, it's not even burning my hand. And that's what's been happening when it's cold and wet out here. Actually, when it's been cold and wet, I've been getting some ice ups. Right, it's not ice right now. But that new board's going to replace this one, and it's going to have, it's going to know when it's frozen. It's going to stop and thaw, and stuff like that. Have a little bit of control. And my goal is to I think I need a bigger compressor. So this is heating my water right now. But that's the controller I have right now. I think I need a little more compressor now that this thing's all hooked up in here, I think, just to get a higher compression ratio. There's a rotary down there, and I think that's not the one for this, but I have the rotary for this one also somewhere. I wish I could get my own controller to work on it. But right now it's kind of heating half-assed until it really finally builds up the heat, the curve. It's just being slow when it's cold and it first kicks on. Hopefully that stayed connected through all that. I'm sure it's all pixelated as hell as this thing's been. Yeah, it's 118, but yes, I can hold my hand on there. When it really gets going, man, you can't even hardly hold your hand on there when it gets the water temperature going. I actually have the water flow as slow as this goes, but I need to do a couple tweaks on it. You can increase the compressor RPM. Well, that's the thing. I have a fixed speed rotary in that, and that's what's haunting me right now. The beauty of, I'm just looking at my screen up there and seeing how crappy my live stream is right now. Hopefully it fixes itself a little bit. It was probably shit when I was outside, I'm sure. The beauty of mini splits with the inverter technology is that the compressor speeds up and the heat pump mode kicks ass compared to a fixed speed, regular central air. I mean, they get down to 0 degrees, no problem. So, but didn't drop out. So if I hold it steady enough, hope it stays good. Now, I have a Wi-Fi router down here, so just for shits and giggles, since I did run this long enough to see how crappy or okay it was, I'm gonna get on my Wi-Fi. All right, it says I'm live again, and yeah, I can see that the video is way better now, right? So everything more clear. Yeah, that looks a lot freaking better than what it just was. So you guys are going on now. Should have been connected to that one earlier, right? Back to 1080. So there's a Wi-Fi router down there that's hardwired from the other one. I wanted to see how that would work, but before I don't think it would hardly stream at all connected to my router. So that the Verizon modem/router is okay. But as you see, going through a couple walls on a big 2-story like this, it screws it up. Now I can look at my monitor up there and see that my video is awesome. 20-something minutes into this live stream. So I'll go back over this just a little bit, play with it before we go play with the VFD out there. You guys are going to laugh at that thing. So what mode were we in here? We're in hybrid mode again. And we're in hybrid mode because we have only the AC calling, but the water heater is below the high limit. 124 degrees, right? So if I crank the water heater up above where I have the high limit at 140, right? This could be 140 something. It's going to switch there. So it's reading the sensors. Now it's 142. So next time it goes through to the mode decisions, which is right here, coming after this, it's going to say mode switch, hybrid AC only, basically, back into my TXV. So the only thing it did there was a quick mode switch was it just needed to stop the pump. It's just not going to reject heat into the water heater because it'll get too hot and lift the pressure relief. The outdoor it has in series now, which it didn't have before on my last Frankenstein, is that my last Frankenstein was only the water heater to reject heat, where now it's the water heater and then through a couple passes of a coil, or half that coil that's out there actually. So now if let's see here. So if I go back to where, let's see, let's turn the water heater on. So it's going to turn the pump back on. I want you guys to see these electronic, there we go, pump's back on, right? It's still controlling superheat based on this one. Suction is right at 10, so let me turn up my suction temperature a little bit so you see when the superheat's too high. See, superheat was 10 last cycle. After it reads the thermistor, now my suction's 71 and it's 50 something or whatever it was going in, so it's going to be like opening EXP to decrease superheat. It's going to keep doing that as it goes through there. So let me go here as it goes through. It's clear enough where you actually see the whole thing probably now. Every time it goes through that step, you're going to see this thing clock open one pulse. So, did you see it? And eventually this thing will just keep going all the way around. I just put the screws in there to kind of stop it for when they home. It just keeps opening that expansion valve. And then if I'm going to cool off the outdoor coil, so it's going to start slowing down this fan right here. So it's still opening the expansion valve because it's trying to adjust the superheat. And it should start slowing down that blasted fan if I cooled off that outdoor coil enough. Yeah, slowing down outdoor fan. Opening expansion valve some more, slowing down the fan some more. Okay, and then at this point, if I don't need the AC anymore, the space temperature, I'll put it way down so it's cold. It doesn't need to, it's below the low limit. It'll switch. So let's go switch expansion valve. So now it's going to go to water heater only, and it's going to do the switch of the expansion. I was just going to put this outdoor one right where the indoor one was. So, and of course, that's just representing one of these. This is a electronic expansion valve cutaway. I had to take the coil windings I had, and use it on the unit when I moved it outside. So this winding ain't working right. But this is still, take this off the coil. This is still that cutaway I was using when I had hooked up before, and you could see the needle, which I just put a piece of tape on it. There we go. There's your little, that's the needle inside your electronic expansion valve, and it opens and closes. Opens and closes. I can, so I have that. I have a big electronic expansion valve around here too, somewhere too. That opens and closes. Fan speeds up when it, again, when it's on the outdoor one. And of course, if I just turn everything off, it's gonna just go to mode 0, which is off. It's going to close both of these. I have it also resetting, so it's going to bang them because I just have it home. This is what I have a program for now. I might take that out later and only home them when the power's cycled. There we go. If you listen to when you first power up mini splits, VRV units, VRF units and stuff, when you first power, you hear them go, they close, and then you hear a more pronounced thud right when those little domes, the needle is all the way, it'll shake. And I've even tested that out in the field. Put my hand in there and I wait, and all of a sudden you feel it, then you can feel it thump. And then the one I made outside, it does the same thing. What are you doing, child? Is this your drink station?
Yeah.
No.
Yeah.
Okay, watch out. I need to go out there, and you're in the way when I'm live streaming.
Hi, live stream.
All right, so it's hopefully everything's still kind of hooked up the way it was, so don't blow nothing up in front of you guys live, right? F it, we're doing it live. So I'm going to hook up, right, this 110 volts here to this plug that goes to this board I made. This is a different one I made for, like, doing stepping up 115 for 230 volt devices. And not to be confused, none of these put out AC voltage. It takes AC voltage and steps it up to DC voltage because inside all electronic motors, whatever, it's really DC in there. They all just charge capacitors. And I've taken advantage of that I don't need to step up AC voltage to AC voltage. I just need to get the DC voltage on the capacitors right. They just go through diodes, a rectifier. So knowing that, I can use a voltage doubler or voltage tripler, which this is, and this 115 volt AC going to charge the first capacitor, with one half of the cycle, and then when it goes the other half, it using diodes, it's just going to now put this in series with the next wave, which this one's across both of those, and then you get double, which I usually need here one, and then the one inside the device is charged to the double. And then with 3 of these or whatever I have in here, then it kind of just does it each other half cycle and basically keeps doubling it up. So this is a 460 volt ABB drive, right? I have this motor hooked up to it, and we're gonna plug it in and watch for sparks. Oop, that noise was my daughter with the soda, not this. So it should kick on. And we're gonna piss this thing off. I think I accidentally pitched the zoom there. So no faults. Unfortunately on the ABB, there's no 2 screws out here to read the DC bus. But you see it doesn't say low voltage. On those Yaskawas I have, they have the DC bus terminals. And I think, some of the other ABBs do. So, and there might be, who knows, some other screws, but I haven't really messed with it. But these are those real basic ones that are coming in staged air volume units and whatnot. So I think it's set for 30 hertz. And we're just going to go to hand. That thing's going to run. Your daughter's going to get her ass scared if she doesn't get here before I ramp this up to like 240 hertz. She has a cup that's overflowing over there. My God, why?
I don't know.
That's going to spill everywhere when you go up that ramp. Drink some of it. My goodness, I can't have any peace. You're supposed to do my area away from the family, but no, now the daughter comes out here and raids that refrigerator. So we're going to hold this up to speed it up. This thing's kind of slow to change speeds, but you push and hold it to get faster and faster. Let's get it to like 60, see here, nominal speed. You probably should. All right, there's your nominal speed. Just get an ear for that, right? And then we're going to crank this to the moon. Now, there isn't much load on this thing. There's getting up to about 90 hertz here. Start to hear those zip ties with the tape on it start to zing a little bit. 150% of your standard, of the nominal 60 hertz, because I went 90 hertz, so it's 150% speed. Because I've allowed to turn the max speed up. Now let's go ahead and go to 120. That thing's really zinging. 200%. Better drink a little more of that before we go up that ramp. That motor's at double speed. And the camera rate's making it look, I can't even hardly see this thing with my naked eye, but the camera's kind of catching it. The overlapping frame rates. So 120 hertz. This is ready to move, man. I know it freaks out. The motor actually, I'm going to show you in a second. Let me get it to 180. So about just under 190. All right, so we're 312% nominal speed, which is 60 hertz. So we're 187 hertz, right? But watch what happens if I keep going faster. I don't think the DFD screws up at all. I think the motor actually just loses like sync with the, because AC motors just have slip in their nature. And of course, we're not driving the voltage up any higher like you normally would need to when you overspeed a motor with a load on it. There's 200. Oh, they just wigged out. See that? 223. When I get up there, I think the rotating field is still going that fast. I think the motor just loses sync because of the voltage versus frequency. And even though there isn't a load, it wigged out. If there was a load, we would get nowhere near this. So once I get it back down, it'll kind of match up again and get closer to 180 or so, if I remember. So it's speeding up as I'm slowing it down. Now it's going to sync itself, catch back up. So it can do like 190, even up as much as 200. That motor's freaking zinging, man. Listen to the freaking 2 zip ties. They're blowing air. Maybe get a piece of paper or something, man. Dude, you can see that thing big. Oh, trying to suck it in. Dude, it's blowing the paper. Oh my goodness, I needed that. It was blowing the paper with the zip ties. That thing's moving so fast. Yeah, it's just stupid shit is still fun, right? Zip tie shrapnel. I know, I'm waiting for it to hit me in the gut or something. Now, when I go back down, I've got to get to about 60 hertz. Oops. 61. 60. 60 hertz, 100% nominal speed. And now the motor is crawling in perspective, you know. In reference, I should say, to what it was just at a second ago. Pretty crazy, huh? Ow, that kind of hurts even at that speed. I didn't want to touch it when it was going really fast, but this VFD never faulted out. I want to hook this up to something. I want to see how much I can actually do. Shock myself at how hot are these diodes? They're not. They're not hot at all. So for testing purposes, this is a functional design. And actually, those capacitors are out of one of those VFDs. Took apart some of those VFDs. Oh, yeah. When they're bad. And I like to save the old ones because they get capacitors are some of the most expensive parts of your project. So, and there they are. So, lead off resistors, relays, all sorts of good stuff. This is just all filtration here. MOVs, metal oxide varistors, which is your surge suppressors, built in. And then filter capacitors, choke. And then your stuff for electronics. Yeah. But it all, when you put in your AC power in these, and I took one capacitor on here, these are all just in parallel. These are like, these are high voltage. They might, this is a 230 volt one. So, but you're like I said, it goes to a rectifier, which seems to be built into this chip. This chip here seems to be the inverter output. What do you want to call it? For the VFD, and it's the rectifier must be built in because I don't see any dedicated rectifiers on this. So they got to be in there. It's just all one block. So when you stick an AC voltage in there, it just goes through the rectifier part and then right to the capacitors anyway, and charges them up. So and then, you know, electronically, you know, has some. Once it gets going, it just uses some switching stuff, which is what this is obviously doing, is switching this to make the stable low voltage. It's obviously feeding through it with a resistor, which is probably this before the relay closes or whatever. I'm guessing it's doing something to activate, you know, your low voltage electronics. As soon as you put power in there, it's bleeding it from the high voltage somehow through some resistor network. And then as soon as it gets it, then it activates the switching thing. So you're taking high voltage. Ooh, almost put my hand in there. Your high voltage is doing a switching thing to low voltage, but everything powers off of this, you know, high voltage, which is 300 volts, 208, 330 volts DC for 230 volt stuff, or 600 volts for 460 volt stuff. And so all you need is just to make it. So I've been figuring that out and making these boards like I can run those ECM motors. I can do that. I could take like 115 and make it 230 and stick it right into any ECM, an X13, an old GE, you know, the Gentex, all that stuff, and it'll power it. I mean, you can just do it on batteries if you have enough, as I've already shown, or just doing this. And then, of course, those electronic motors, so all that. So I want to see if I can do it enough to run like an actual compressor or something, a small one, like a 1.5, 2-tonner. So I have two goals now, and one's to try to get that. I just shredded my schematic, but I want to make my own. It rotated. I'll have to print that out again. I want to make my own driver, hopefully to run the small inverter compressors. And then I want to maybe just look and check out, like, these are old Mitsubishi chips off those small little inverter compressors. These are obsolete, they say, but I'd like to find out what they're using in the newer ones, maybe a Carrier one or something, because I have some of those old ones here. If I dissect it and see what they're using, and maybe if I could find the chip online, it's not that much, I'll be able to just use one of those instead of all this discrete stuff, which is all this. But for now, I want to make one of these work and just get it to run an ECM motor or something to stew around. And if I could get it to work on 300 volts, you know, by modifying the circuit, so where I can do a high voltage bus right here is where your bus goes. That'll be awesome. And if I, for some reason, just get to the point where I can't run one of those compressors like I want to, maybe there's just a lot more to it. Maybe I'll just get the smallest scroll compressor or something, like a 2-tonner. I found there's a 2-tonner 3-phase scroll. You know, I could slap that in that unit and use one of my VFDs and drive that thing all day long. But I'd like to run some of those little mini split compressors. I think, and I got a couple of them already. So that's kind of the go. I left this on. It usually stays on for another second. Plug that. Kind of fun stuff. There's all these projects I don't finish. This thing here is a tank. I put nitrogen in it, and it held 150 for a while, and it slowly bled down over like 2 months that it's been sitting here. But I have a solenoid on here, and what it was is I didn't want the dog getting behind the couch. Now the dog's too big to go behind there. But I was going to make this with a laser eye and have him go across it and have it go just scare the shit out of him with nitrogen, or put like a little horn thing on there. I don't know. It was something I was going to do and didn't finish, and just scare the hell out of the dogs who wouldn't go back there. I still want to do that to scare the cats from going under beds and stuff. So let's check the comments again. Oh, you know what? It's weird. This comments up here seems to have not continued once I lost connection. Maybe if I hit reset up there, it's probably going to put the newer ones up there. Maybe not. Seems like I got it. Oh, no, it was the same person. Okay, they're still up there. So what was he seeing? I was trying to read some of the comments. Big serious but with no torque, it just stalls. Yeah, and I think if I had a load on it, it would have stalled way earlier. And I obviously at some point with my little voltage doubler tripler thing that's on there, it would have ran out of juice, voltage sag. So I do need to get a blower or something with one of those motors hooked up, something with a load. I don't really want to put an axial fan on that motor because that's just too scary to get a finger cut off or something. I'd like just to put it on a squirrel cage or something, somewhere with some sort of actual load, a pump, something. Got to find something 460 volts with a load and see what that thing can do. Watch those diodes get kind of hot, but I think I could take that exact thing I have there and just put some better diodes on there, maybe some with some heat sink. And then even double up the capacitors if I ever need, on that same design to run something like a small compressor or something. Be kind of cool. But it seems like that thing right there was pretty robust. And let's see. Read some about the solar panels. Turn that thing off. So this is supposed to be a quick video. It's 40 something minutes into it, but yeah, this thing, I'll have to say, funny thing is I'm only using one compressor instead of two like I was in the summer. In the summer I had that thing hanging on the wall that was dedicated to this, and then it had like the slightly smaller rotary on it, but it kicked ass for the summer. And then I had that thing you saw outside hooked up to this, cooling me off once I got it running. And this thing had enough to run that and top off the batteries. Well, when I had the one bank, and then I added the second bank towards the end of that. And then, but as soon as summer ends, I noticed I hasn't been able to charge up all the batteries. And then now I'm only running one compressor, but the water heater's running like all the time. Oh, that it's still running. But now that's getting pretty hot. But see what I'm saying? I'm losing energy because it's taking a while to get that curve going out there right now. So I got to see what I could do about that. So it's using energy just to get it really into where it starts making good heat. It is only pulling 1200 watts right now, not 4500, but it's still wasting energy. So it's already, see, it's not on solar. I did set it to where it doesn't drain the batteries down as much because I want to save some battery too. So right now we're not using all those lithium batteries. It's not topping it off. It's not even hardly getting it up to 50 volts. By time, I don't have any good sun this time of year. And then, we're only taking it down to like 46 point something, and then I have it switching over. So it's not. It is using solar power when it can make it, but it's just mostly, this thing's mostly been running on utility right now at this point, unfortunately. But when I get that thing to heat up more efficiently, it shouldn't run as much during the day, and it should get the batteries a little more, and then I think the ratio will shift back a little bit, even in the winter, to using as much solar power as possible. Of course, this whole room runs off of this thing, so whenever I'm out here, it's using it down. But anyway, but it should be like 1,200 watts right now. 1,400 total. So it's, but I have the computer on. I just turn off the lights at like almost 100 watts. Drop down to 1.3. So 1,300 watts. It's probably running 11 to 1,200 watts for that deal out there, because this still runs a couple hundred when that thing's not running. And people keep using the hot water to do dishes and stuff too, so it's hard for me to gauge this thing. Once summer ended, this thing gets used like silly. I still want to get a small water heater and put it over for the kitchen that's on the other side of the house that the water goes underneath and over to, and they run it forever to get it hot. I'd like to get a small tank from over there and resurrect my old small unit and like put it outside, little capillary tube system, and have it heat that water heater up over there. So it'll be on its own. That'd be kick-ass. So anyway, I just thought I'd make a video, a live stream. I definitely wanted to record something before I took this apart. I don't know how much longer I'm going to have it apart together, because this is kind of almost ready to go. I think I'm going to go ahead and make a little base plate, maybe cut it out on my little CNC thing there, and like add all these little boards on there, next to each other, voltage regulator, all that. I have the ones that's out there now, but I'll probably just pull that out as one whole unit and then slap in this other one. I just have to stick all my thermistors on there, power stuff, but I'm just gonna pre-make it up with all the little ribbon cables and stuff again. It should be good to go. Oh, and the program code, I think I tried to show that before, but it's all condensed down, the C code, XC8, but this is just main closed loop, forever loop, but and there's my determined mode. But once it gets up in here and starts doing all the subroutines, there's a lot of code. So this expanded out, determined modes, and half of this is just visual stuff for me to see, but these are all my if statements. These are just logical statements, and they work. If the water heater stat is 0 and the air handler stat is 0, well, that's mode 0. If the water heater is 1 and the air handler is not, well then, and the space is less or equal to 72, then that's just mode 1, which is that's the heat pump only, I think. And then if the water heater's on and the air handler stat was off, but the T-stat, the space is greater than my low cutoff, then that's going to go ahead and be hybrid. So there's a bunch of things that can be hybrid. That, or both thermostats are on, or the water heater stat's off, the air handler stat's on, but my water heater is below the high limit cutoff. Again, like I said, whenever you're using some energy, you want to go ahead and use that same energy for the other thing as long as you can. So if I'm heating water, go ahead and cool this room until it gets too cold in here. If I'm wanting to cool the room, the water heater happen to be off on the thermostat, well, it's going to keep driving heat into that water heater until it reaches that high limit. So all those will bring on call for mode 2, which is everything basically. And then if the water heater's thermostat's off, the air handler's on, but the water heater was over that high limit, then it's just mode 3 AC only. So I just made all these modes, right? And then mode 4 is defrost, mode 5 is freeze. Oh, I didn't show you guys those, but both of those kind of work. This is an air defrost. It just turns off the compressor, turns the fan to high out there, and then it's a 30-minute fail-safe, or unless like the coil sensor gets above 35 or something, and then it'll kick it back on. And then freezes if it does that, basically indoor coil freezes up. So those are just what determines modes, and then this is how it tells when modes switch. And this actually came out pretty easy, believe it or not. I was kind of thinking about it when I finally did it. Worked, but so if the mode doesn't equal the previous mode, then it's going to be like mode switch, and then it's like, well, what is that going to be? Well, it's going to be these different situations. If mode is 0 when it was previously, if mode's 0 and mode previous is 0, and this is, I put my little notes in here, when mode changes from any run mode to 0. So it's basically now the mode's 0, and it previously was not 0. I mean, it's going to basically mean any time that all the thermostats are off, when it was previously running, and it says no matter what, it's going to go to my compressor shutdown subroutine, which also shuts down the expansion valves, all these different things that are programmed in there. If the mode is 1 and the previous mode was 0, that means it's just turning on to this mode and this. And I have all these different situations, just a handful of them, and it kind of works. It makes them all, that's how it all switches properly. Either it's going to do a startup, it's going to do a shutdown, or it's going to be switching from one to the other. Switching the pump, whatever, and all that worked pretty sweet, actually. So that's the determine mode subroutine. I have, like I said, defrost subroutine. As there's a bunch of stupid graphics in there. What it does, it's counter timer down. I have a timer counting down in both of these. It's a simple one for the freeze stat. All these are a subroutine. It just goes through compressor shutdown. That one's a real simple one. Compressor off. It's gonna duty cycle for the fan goes off, pump goes off, supply fan goes off. Just it makes sure all that stuff is off. Compressor start. There's my EXP switchover subroutine, which is the one where it determines which mode I'm going from one to the other and then switches the EXPs. This is probably all blurry on the screen, but just gonna give you an idea of just that there are subroutines in here. Closing the EXP, the one of when it starts it up and opens the EXP. EXP control, which is superheat, determines to do superheat and everything. Yeah, skips for that counter and everything. Outdoor fan control, which is pretty simple actually, but it works. It's similar to what I was doing before out there. Thermistor read. This one's got some nitty gritty in there because it's got the, I have some display, and then it goes through, loading my proper analog to digital channels, commanding the chip, enabling it, to whatever channel it is, and then setting the go not done bit to 1, and then while it just kind of sits here until that's done, and then I'm going to have it do this, and then the next one, and I added a bunch of stuff in there just to make those arrows go across the screen, just for an animation of when it's reading thermistors. Let's go ahead and power it on. But there's, all those, plus then they get, after it reads them all, it just has it displaying them, kind of the way I like it to display, loading in my custom characters, all that kind of stuff. So that's a pretty long, kind of a long subroutine, but not too bad. It's up to 93%. So right there, you just missed it. A little animation. That's when it puts all 6 thermistors on the screen at once. It's in modes of standby. There it goes. See, it's doing less stuff now because it's not actually running. But you see that little animation. That thing could be within several microseconds and be done and not even put any graphics on there. But I need to slow it down the subroutines anyway, and just kind of cool just to put that in there. So it's kind of cool to watch this stuff work all autonomously. So turn that back off. Yep. So anyway, let's see, check the comments. The axial fans have a pretty low max safe RPM. Pretty low. The axial fan? Oh, you mean like a metal one? I don't know what that. I mean, you guys know about. I keep meaning to end the video. This axial fan here, it's fucking scary to run it without being in the unit, and even in the units, this is the intake. This thing wants to suck your freaking hand into it. dude, this thing's like a mini jet engine. I don't know what the RPMs are. It maybe just looks like, I don't know. It's definitely spinning because you get the centrifugal or whatever, kind of effect of a gyroscope when it's running, and at the same time it wants to suck your shirt or your hand or whatever into it when it's running. So that sucker's freaking scary. So that's a 230 volt one that I've also ran with this, and it pretty much gets really fast before it like clips out from voltage sag. So it could move quite a bit of air actually. And if I just built this a little bigger, it'd be fine. If I get my hands on one of those 460 volt motors, I might try it with this thing and see what it's capable of. But I don't know, that AXA fan, I definitely think it's moving faster than like a 1700 RPM motor. It's pretty sketch on that AXA fan. And I need to get myself one of those tachometers or build one and put a piece of like tape on one of the blades and then see what their actual RPMs are. It's pretty fast. And who knows? I don't know in the those come out of the carrier units, so I don't know if that actually has it listed in their product data, because I know it actually does for the fan motors. Well, because it's telling you what to set the blower wheels RPMs for a CFM are, and you're multiplying it with the or dividing it with the pulleys. So they probably don't tell you what that RPM is. There's no reason for them to, but it's pretty. It seems like it's pretty freaking fast. It's gotta be, man, because when that thing's going slow, it's making like, and you look at a 1700 RPM fan motor, you can almost see the revolutions on that with your hand, with your eye. So I guarantee that AXA fan's got to be multiples higher than that. It's got to be up there. We'll find out. So, but you definitely saw that three-phase motor out there hit. I set it from 60 hertz to 240, which is 4 times its speed. It didn't get to 240. It starts screwing up about 200, but you heard how it is when you drop it down to 60. It sounds like it's crawling. So, but remember, we're used to think like an AC motors. It's always determined on the pole. So what is it, like a 6 pole is like your 850 RPM ish, and then your 4 pole is your 1700 RPM, or I don't know, sorry, not is like a 1075s, and then your, what is it, 2 pole is the ones that are like faster, and it depends on what kind of motors, I guess. 3-phase versus single, but single phase is the ones that are 850 and 1075, and then on your 3-phase, yeah, it's like 1700 or 3000 ish RPM, yeah. So like 3600, like you're saying. Generators are the same way. So like to make 60 hertz on the amount of poles, they would either run them at 1800 RPM or 3600 RPM. So the good generators would be like a more torquey 4-stroke, like in a motorhome or something, for quiet. But then some of those cheap generators, they would be like 3600 RPM because they have a wimpy motor, so they just have less poles and then run at 3600 RPMs and get your 60 hertz, And then some 2-strokers, same way, man. 3600 RPM, just crazy. So, yeah. And when I was saying 1075, 850, that was like not a 3-phase, but a single-phase motor. So I think they're 6 and 4 pole or something like that. But I think in a 3-phase motors, I think they're like 4 and 2s, right? 4 for the 1700 and 2 pole for the 3600-ish range. They haul ass. And then, yeah, 50 hertz for the rest of the frickin' world. So, all right, well, it's 10 o'clock. So, hour. All right, well, nice hanging out. Hopefully the video comes out. Looks like it's a little screwy again, but live streams are usually kind of good for, just messing around and chatting, but not for the quality of leaving up on the channel. So anyway, with that, I'll catch you guys later, man. I got wrapping up and get to bed, man. We'll catch you later, man. I'm kind of cutting them off, but if I don't get out, I'll never get out. So anyway, I had something to do, so I'll catch you guys later. Yeah, catch up with you later, man. See you next time.